Git has been installed in my machine. I hope you also has installed the Git. So if your Git is ready, then it's time to explore about Git in depth. So let's check Git configuration, and we'll look into some of the terminology or vocabulary of Git. Let's begin with the Git configuration. So what is Git configuration? So Git configuration requires us to configure our username and email that will be used during code commit. So to perform this configuration, so what will we do is we will go to the Git. Okay, let me click on Git bash and then open it. Yeah, I'll keep it here. Yeah, let me make it bigger. Yeah, it's fine. So let us do the, because I have opened the Git only. So this is the Git. It's the CLI tool for Git. Git bash is the command line interface for Git. So now we are going to execute some of the commands so that we can configure uh, configure uh, Git with our username and our email. So we are customizing. So the first one is Git is the main command, and then sub command is config, and then we'll go with the option global. It's a global configuration, not local. So I'll global configuration. Then I say user dot name, that's attribute, then give space, and I'll mention this is Surya and then Charan. Okay, and let me execute this command first. Done. So then we will config email also. So global option will go with the global long option. Then it is user dot email. So and it is, I'll give my email. Yeah. So email also been configured. So now how do you get to know whether it's been configured or not? How do you get to know? So to do that, to check the configuration, to validate the configuration, so we can check the configuration values by executing git config, and then we'll use a global option, a long global option with a long list option. There won't be any argument. That's it. Git config and use global option and then a list option. So this list option lists out all the configuration details which are related to the global. That's it. User dot name is Surya Charan, and email is this. So that's how we config our git initially. So always and always you configure, you make git configuration, then only you start working on the other aspects of git. So now let us look into git vocabulary. So git is now configured and is ready to use. So git is a tool that is very rich in objects and terminology and has its own concepts. Before using it, it is important to have some knowledge of its artifacts and the terms that compose of it. So here is the brief list of this vocabulary. So it begins with a repository. So what is a repository? So a repository is the basic element of Git. It is the storage space where the sources are tracked and versioned. There are remote repositories that centralize a team's code and allow team collaboration. There is also the local repository, which is a copy of the local repository on the local machine, or it's a copy of working directory on the local machine. So let me demonstrate this on live on my GitHub. So let me go to the browser, click on, go to the Google, and then type GitHub login. Let me sign in to the GitHub. Yes, my GitHub account, it's been signed in. So I will directly want to show the repository. So whatever repo that I'm going to show, these are all remote repositories. These are not local repositories. Local repository I cannot directly show. Once we execute our first git init, after that I can show the local repository. But for this moment, you see the remote repository. Go to this profile, and then profile drop down menu, drop down button, and click on your repositories. Yes, of course, these are my repository. I have a lot of repositories here. That's okay. And then, so these are called repositories. So what is a repository? It's a remote repository specifically. It's a remote repository. So repository is the basic element of Git. It is the storage space. In a simplest way, it's the storage space where the sources are tracked and versioned, where the sources are tracked and version. So example, I'll show Ansible projects example. I'm showing this is one repository. So this repository is like a storage space, and this storage space consists of plenty of resources or sources, and these all can be tracked and versioned and can be maintained. So that's our repository. I hope you understood what is a repository. So now let us look into the one more terminology, that is clone. Clone Cloning is the act of making a local copy of a remote repository. That's it. Clone. Na? We say clones. These people, and you clone that. You clone this. Even in Photoshop, we use that word. We have a clone tool even in Photoshop. So clone is nothing but an act of making a local copy of a remote repository. So now let's going to do a local copy of a remote repository. So for that, I'll go to my repos. I will get back so to the Surya Charan Teja. That's the here I find all the repos. I'll click on the repo and I'll select ML repos. I'll select machine learning repo, my ML Madhu ML. This I am going to select. I don't know whether it is, yeah. So my ML is the repo. So I'll copy this HTTPS link, and then I'll get back to my git bash and I'll type git and then clone, then give URL, HTTP URL of that, and then click enter. So git clone has been executed successfully. You can see the cloning into this repository, and it consists of 3 objects, and all the 3 objects has been downloaded. So now let me check the status of it. Clear, and then let me check ls. Oh, the wrong place. I have cloned it into a wrong place. Let me close this, and because it's a huge repo, of course, but what I'll do is I'll close this, and here is my hands-on, and I'll open one more directory here. It's git vocabulary demonstration. Yeah, here I will open my git bash, and I'll make it bigger, little more bigger, horizontally little more bigger, and zoom it. I'll say git clone, and then a repository URL. Oh, that's wrong one. Sorry. I'm sorry. I'm sorry. Yeah. So paste the URL as it's cloning into. So it's been cloned, and let me check ls. Here it is, my ml. So that's what we got it. And let us check here, my ml. This is our repo. This is our working directory, and this is our repo. Okay, that's how we clone the repositories. That's how we clone a remote repository. Cloning is nothing but creating a local copy. Then we have the third the third term, that is commit. Commit. What is a commit? A commit is a change made to one or more files, and the change is saved to the local repository. So each commit is unique and is identified by a unique number called, it will give a unique number, says sha, and then hyphen, and then different numbers like that. So each changes, and that will allow us to work in isolation without affecting the master branch, without affecting anything. So this is how we commit the code. So let me show in a simplest way. I cannot show the exact code now, so exact commit now, because we have to do an exercise for that. But at this moment here, you see, so what is commit? The simplest way, what is commit? Committing is a taking snapshot. That's it. That's it. So here, this is the initial state of my logo. Then after that, I have changed this to this color. So this is my, I have done a change. Now this change should be added. Once it is added, then I have to commit this change. Commit means I'm saving this. That means I'm taking a snapshot of that change and I'm putting it into a separate file. Same. I have done some changes and then I have take the snapshot. Then I have put it into a separate file. So each has their unique ID. Their unique ID, unique number. The first one, unique number is 2. The second change unique number is 3. The third change unique number is 4. The fourth change unique number is 5. So this is what the analogy for commit. Commit is nothing but taking the snapshot of changes or saving the changes in a simplest way, either saving the changes or taking the snapshot of the change. I hope you got it. So if you want to use the command git and you say commit and you give m, that's as a message option, then you type, okay, this is my first commit. I'll say first commit ever. It's saying fatal. It's not a git repository or any of the parent directories of it. Okay, we are not in the git repository. Let me enter into the git repository and give the same command. So now it is main branch. Okay, what is branch? We are going to see. So now I will give the same commit and we'll see what is going to come. So git commit, I said git commit. It's saying on branch main, your branch is up to date with, so nothing to commit because we haven't done any changes to this. So there is nothing to commit here. But I hope you got the analogy. If you got the analogy, then understanding commit is damn easy. So then we have branch. So what is branch? Branch, what's branch? The code that is in the repository is stored by default in a master branch. Master branch in GitHub and main branch. Main branch in GitHub, if it is our local machine, it's a master branch. Okay, so a branch can create other branches that will be a replica of the master on which the developers make changes, and that will allow us to work in isolation without affecting the master branch. At any time we can merge one branch into another branch. So as I have shown you this here, if you see, it is showing as a main branch. The branch is main branch. Now we are in main branch. Inside that we have only one file, that's readme.md. Readme.md. So if you want to create, if you create a new branch like version 1, then version 1, so that branch, if you create a new branch with version 1, and that branch is going to copy the same files from here. As I have said, branches are an important part of working with Git. So any commits you make will be made on the branch you are currently checked out to use. So let's use Git status to check which branch that is. So we are on branch main, so that you can see on screen. Okay, here you can check, but still you are on branch main, so your branch is up to date with the origin / main. This origin is the remote one, and then main is here the local one. So sorry, origin is the name of this branch, the what we say, uh, we have given the pet name, kind of pet name for this, and main is the branch name. Okay, so that's it. So now let's create one branch. Now we are in main. Let's create a branch. Git branch and say branch name is first branch, or we'll say version 1.0, because it's normally we create branches for versioning, na? So that's the reason we'll say version 1.0. And then let me enter. So the branch has been created. Just to cross check it, let us check into that branch. Let's check out to branch name is version 1.0. That's it. Now we are in version 1.0. Let me clear the screen and show you. I'm in version 1.0. So what is there in this? ls readme.md. Readme.md. That's it. That's the magic. That's what the branch is in uh, in in Git. So if you see, we have two branches, and each branch has a readme.md. Let me check out back to main branch. It's a main branch. Sorry, Git checkout main branch. So now switch it to branch main. So here let us see, ls we have readme.md. So here the same thing has been copied when you create a branch. So here how many branches we have? Branch 1 and branch 2. Two branches we have. Git status. So two branches we have. But we have only one directory. Let's get into that. So this is our working directory. This is our working directory, but it has a two branches. Those two branches, that's what we call, that's a separate, that's called a local repository, because it is in our local machine. Whereas this one where we are working now is called present, it's called current working directory. I hope you got the difference. A current working directory is the one which actually exists, whereas local repository is delusional. It exists in a staging area, and after that staging area it exists. Okay, it's not here. You can see two branches, and you can see two branches, and you can see the, you can't enter inside the branches at this moment, at this point, exactly in the current working directory. So the differentiation you have to make is, one is current working directory where you are working, which actually exists in your Windows machine, and second one is a local repository that you can find out using the branches, and the third one is a remote repository that you see in your github, in your github account. Okay, so finally, if you want to merge, you can just use git merge and then branch name with version 1.0. So it's already up to date, so there is nothing to merge. But before the merging, let's go to that. Let's see what is the next terminology that we have. Then we have branch merge. So git merge combines the specified branch history into the current branch. So this is usually done in all pull requests, but it is an important Git operation. So the code that is for merge, this is the action that consists of merging the code of one branch with another branch. So let's do the we will at git checkout. Okay, before that let me clear the screen and bring this to this side. Yeah, so we are testing merge now. So git checkout, and what is that? Version 1.0. Yes, we switched to version 1.0. Here we have ls read.md, only one file. I'm gonna create touch two more files. I'll say file 1.125 and .txt. Let's see now how many files has been created. 5. So let's get back to the git do the git checkout. Back to main. So we are back. So let's do the git merge with version 1.0. It's already up to date. So version, the git main is already up to date. So then checkout. So what is checkout? The checkout action we have seen. This is checkout. This is the action that allows to switch from one branch to another branch. So let's check out one more time. Clear the screen, and then here but before that, so after the merge you can clearly see all the files has been copied, all the files has been brought back. So one more time I just want to reiterate the purpose of merging is it is mainly for versioning. What is versioning? So versioning is you have a base code. So on top of that base code you want to add few more features to that application. So in spite of directly changing the base code, what will we do is we will create version. So we'll create version. That is one use case. I say git branch, this time I create version 2.0. So now I will add these new features. Anyway, when we do this, automatically the existing code, the base code will be automatically copied. So now we will add a new features into this. So I do vim read mg. So in this I will add new features should be added. Then I'll save this. So new things has been added into this. Now let's see. So this is the one. Okay, sorry, we haven't checked out to the version 2.0. Okay, first we will check out to the version 2.0. Git checkout version 2.0 ls. You see all files has been copied here automatically. When you create, the base code will be copied. Now let me do vim read mg. So as usual, so this consists of the 2 lines. So now I will add one more line here. So that means I'm adding my new features. So feature 1, feature 2 and module 3. So then I'll save this. Now without merging, let's get back, let's check out this checkout to main. So git checkout to main. So your branch is up to date. So let's do ls and cat read mg, all the features has been come. So that's how uh, the main, so basically merging and checkout will help us in navigating from one branch to other branch. So this is the power of branches. So branches is mainly for versioning, and one more use case of branches is for the debugging. So when you are doing a debugging, you want to find a fault and you want to add some piece of code to that to solve that issue. In spite of changing the base code, you keep the base code in main branch, and then you create a version called debug. Git branch debug version, debug branch, and then anyway base code will be copied here, and then you change the code here. You do the debugging using vim readmd. So you change this, whatever module is, whatever piece of code is throwing error, you remove this and save it, and then you do the git merging with the main branch. That's it. If it is successful, you merge it with the main branch or base code. If it is not, just keep that keep that debugging branch like that. That's it. So now let's look into the fetch. So fetch, this is the action of retrieving the code from the remote repository without merging it with the local repository. So git fetch actually downloads all history from the remote tracking branches. So at this moment, this branch has a remote, this present working directory, there is a git initialized in it, and then at this moment we are in a local repo. What we are playing in a local repo. You see, main branch, it's a local repo. When I come out of this main branch, so now if you see, this is called present working directory. Once you enter inside the git, it's called local repo. So cd local repo. So now when I say git and then fetch, it's going to fetch the history of the remote repository. Then we have pull. So as usual, a pull updates your current local working branch with all new commits from the corresponding remote branch on GitHub. So git pull is a combination of basically git fetch and then git merge. It's like there is a new piece of code in uh, something. See, I'll tell you one more example. So you have to explain each and everything with example, then only it's possible to understand. Okay, let me clear the screen. So let's take this example. So this repo, uh, the GitHub repo, this is the repo. So all three people are working on this repo. Three developers are working on that. So I pushed a code, and other one also pushed a code, and now the third one. So before he pushes the code, he has to pull this code from this repository, and he has to integrate that with the local repository. Then he can push the code. So for that, if you pull the code, means it will fetch the code changes in the remote repo. That's where here, and then after that it will merge that changes with the local repo. That's what the pull is a combination of merge and fetch. So git pull already up to date because there is no changes here. Let's get to the GitHub. Let's add a file, create a new file. What I'll give this is, I'll type this script.sh and bin bash and pwd date. That's it. It's more than enough. And let's commit the file. Of course I haven't added any message, that's okay. So the file is ready. Now let's fetch. Before using the pull, let's fetch git fetch. So remote enumerating objects 4 done. So it has fetched this from the remote main to origin main. That's the local main. So now let us check the local main. It got with the script file also. Okay. So now in spite of so we got fetched it. Now we have to merge that with the local one. So git merge. So now updating that, fast forward. So here you can see script.sh. This is the one file has been changed, and these 5 insertions has been done to our local repository. So literally from remote repo we are bringing it, we are fetching the data from remote repo and we are merging it with the local repo. Now you do ls, here is the script.sh. You can see that in green. Okay, so that's what the git fetch and merge do. So now what will we do is we'll create one more file, create a new file. I'll name it as code.py, and here I will add x is equals to 1, y is equals to 2, and x plus y is z, and I'll print z. So again, this is commit message python code, and then commit a new file. So new file has been committed. Let's get back to this, and let's say in spite of fetch and merge, we will say just git pull. That's it, game over. So it has fetched the data from, fetched the files from remote repository, then it has merged the files into local repository with one command. Let's do ls. Here is that code.py, the python script. I hope you got the purpose of merge, checkout, fetch, pull. So then finally push. So what push does is a push uploads all local branch commits to GitHub. So push is the reverse action of pull. It allows us to update the remote repository from the local repository. So let's get into our local repo. So this is our local repo. So let me clear the screen. We are in the main branch. So let me create one file. I'll say touch, and then of course we have added so many files. Now we have a lot of files in the local. So this, so we'll do git add all. So we'll commit, git commit all these files with commit message. This is the first commit to remote repository. So the commit has been done. So basically what is commit? Commit is nothing but the changes, whatever the changes that you have done, all will be captured and takes the snapshot of it and saves as a file with the specific unique ID. That's what had happened here. You see, create mode file1.txt, file2.txt, 3, 4, 5, all the files has been changed, and these are the 3 insertions. Let me give git status. You see that here. So now use your branch is ahead of origin or main by 1 commit. Okay, my branch, local branch, this is a remote branch, it's ahead by 1 commit. So now you use a git push to publish your local commits. I have almost 5, you see, 5 files. I have to commit all these 5 files. For that I say git push. That's it, it's been pushed. So you see here, so total 4 all been done, all been done. So now let me get into my GitHub. And here is the magic. See, file 1.txt, file 2.txt, file 3.txt, file 4.txt, all files has been pushed into the remote repository. So this is how you can connect your local repository with the remote repository in GitHub. This is how you can interchange the files from local to remote and remote to local using the commands such as git fetch, merge, push, pull.